What's your problem? What's your solution? This is an interview series about making the world a better place. In the campaign to reverse global warming, most scientists, politicians and entrepreneurs look for new technology. Solar panels and windmills need to replace coal-fired power plants and electric cars, gas-powered cars. Throughout history, new technology has driven the progress of humanity. Amory Lovins, the visionary founder of Rocky Mountain Institute, has a different solution for global warming. Yes, there is a place for solar panels. However, the key to a healthy and sustainable planet is first and foremost better design. Integrative design of whole systems rather than individual parts will dramatically improve efficiency and with that, energy consumption. Amory Lovins has led the global conversation about energy for more than 40 years. As a guru of energy efficiency, he has consulted with many governments around the world and he is the author of numerous books. Better design is a simple solution. Amory Lovins is a scientist who grows bananas in his home high in the Rocky Mountains with no furnace. Welcome to the Climate Solutions Summit. Why are you growing bananas at 7,000 feet in your home?
Well, when we were building this passive house, it used to go to minus 40 and below out here, and we thought we'd start a little garden, and then somebody gave me a banana tree, and it just went bananas.
We're speaking in wintertime, and just the past night, the temperature was 20 below. You have not been using heating in the house?
No, there isn't a heating system, and the house gets all its energy from renewables. And actually, if you were to build it now, it would cost slightly less than normal to build. The reason for that is that you save more construction costs leaving out the heating system than you spend extra for the insulation and other things to get rid of the heating system.
I come from a country where the sun hardly shines. I mean, so you have, of course, the benefit of a lot of sunshine here in Colorado. But if the sun doesn't shine and it's still as cold outside, your house stays warm?
It won't be quite as cold outside if it's cloudy. Mm-hmm. It gets very cold only in the clearest weather, but there are indeed, last I looked, 160,000 passive houses certified in Germany, 2/3 of them, I'm told, from fixing up old houses. And they're all over Europe, and in fact, in Holland, people have invented a lovely way of going to a net zero energy house, one that produces as much as it uses, not from super insulating the inside with costly craft labor, but from industrializing a kind of tea cozy that you put around the house. And that has been done just to show they could in as little as one day while you're off at work. And that's getting cheap enough now that it can be financed just from the energy savings without subsidy.
A few years ago, when you were still in college and you were thinking about
More than a few, I'm 71.
Well, granted. But still, you went to college one day and you were thinking about the career you're going to have. How did you come to this, to energy? And was there an aha moment, like, this is what I'm going to do?
Oh, let's see. Well, that first climate paper in '68, and by '71, it was absolutely clear that the world was headed for serious trouble with energy. And so I went to my colleagues. I was down at Oxford, and said, I'd like to do a doctorate in energy. They said, energy? What's that? It's not an academic subject, is it? We haven't a chair in it. Pick a real subject. So I went off and did it anyway because it seemed to be important. And 2 years later, they realized it was important, and really haven't looked back. I've been very busy ever since. And then 5 years after that, was fortunate enough through a series of accidents to be able to reframe the whole energy problem. We were asking the wrong questions, and that's often what happens. When you get the question right, that's the hard part. The answer becomes self-evident. But until '76, people thought that the energy problem was, where do you get more energy, more from any source of any kind, at any price, that sort of curve. And I thought it would make more sense to start at the other end of the problem by asking, what do we want energy for? We don't want barrels of sticky black goo and lumps of coal. What we want is the services that using the energy provides, like hot showers and cold beer and mobility and comfort. So for each of those so-called end uses, each of those services, we ought to ask how much energy, of what kind, at what quality, at what scale, from what source, will do the job in the cheapest way. So that came to be called the end-use least cost question. And by now, anybody with any sense in energy uses it, and it permitted much better insight, much better competitive performance.
So energy conservation is a major component of any attempt to reverse global warming or deal with climate change.
Using less energy through smarter technologies is saving twice as much energy as we're adding in the world each year through extra renewable supply.
So when people talk about energy efficiency, they quickly talk about diminishing returns. You can't sort of keep squeezing more energy out of a certain unit. That is the thinking, right? But do you agree?
If you design a building, a vehicle, a factory, a piece of equipment as a whole system for multiple benefits, you'll get several-fold bigger energy savings and lower costs than normal design where it's just a pile of parts and you optimize each part and then they end up working against each other because they're not designed to work with each other. It's a very simple idea, but most things are not that use energy are not designed in that holistic way. And if we do, we will find that this old economic theory of diminishing returns, rising costs, actually is backwards. With integrative design, whole system design, the savings get bigger, but the costs go lower.
Is design, like you envision that, and you're doing it at Rocky Mountain Institute, that kind of design, is that being taught in engineering schools at all?
Integrative design is starting to be taught a bit, but the world's a big place, so we need to get better at spreading this knowledge. And of course, we're not the only ones doing it. There are now many excellent designers who are taking this on. It just hasn't quite penetrated a lot of the official thinking yet, and it's not getting through to many of the economists because they're so convinced that saving more has to cost more.
But it is interesting, while this is going on, and you've been working on energy conservation and efficiency for decades, the conversation about global warming and renewable energy is mostly about new technology.
New supply technologies.
Yes.
Yes, the shiny objects.
Yes.
And the reason for this, I think, is rather straightforward. Even though you can see solar panels on the roof and wind machines over the hill, you cannot see the energy you don't use. So even though it is now the world's biggest energy source, bigger even than oil, it gets maybe 1% of the headlines.
If you read the front pages or watch the news, the predictions are very dire. Is it as bad as it's made out to be from your perspective?
My first professional paper on climate change was 51 years ago, 1968. We knew at that time that if you reach certain tipping points, you could set things into a different pattern.
Yes.
That you couldn't get back from. So we are starting to realize how bad the scientific news is. We haven't yet started to realize how big the menu of mitigations are and how profitable most of them are. We have a large and rapidly expanding set of very advantageous solutions. We know how to do them. We have the technology. We can make money on them. All around the world, there are these centers of innovation springing up where people are starting to realize how big the opportunities are to use energy in a way that saves money and end up with climate protection as a free byproduct of lowering your energy costs.
So the reports that we get about the forecast for climate change, they continue to be, provide worse numbers. But you also say that the reports don't take into account the gains that are being achieved at the same time.
There was recently a whole issue of the New York Times Magazine devoted to an article saying, among other things, that we have only a 5% chance of avoiding the already unacceptable 2-degree warming. Well, if you look back at the scientific paper that's based on, it assumed that we will be abating the CO2 emissions a lot slower than we actually have been since 2010, because the models tend to be based on old data before 2010. But starting around 2010, there was a rather abrupt uptick in the rate of saving energy and the rate of producing energy without carbon release. So actually, when you add up what's happening in those two areas with this recent acceleration, you find that we're already most of the way to a 2-degree abatement, and in some years like 2016, we're actually already there. I'm quite encouraged with how quickly efficiency and renewables are catching on, taking off, and reducing carbon and cost.
The big threshold that the climate scientists in the IPCC talk about is that 1.5 degree centigrade temperature rise globally. That would kick in all kinds of unwanted effects. The last reports suggest we can't beat that anymore. We have to face the reality, and we will cross that threshold. What's your perspective on that?
I think the 1.5 degrees is indeed a prudent limit, and I hope we end up below that, which will be even more challenging. But over time, I think we can do that. There are some very important short-term things we can do with gases like methane that have a very pronounced near-term effect to decelerate the carbon train. And also, of course, we can take carbon out of the air by reframing the way we do farming, forestry, grazing, and the like, so that we're no longer treating soil like dirt, but helping the organisms in the topsoil and the plants themselves absorb and keep carbon. That's what they're designed for. They're very good at it. We don't need to engineer them. Actually, we need to get out of their way and help them do what they have spent billions of years evolving to do.
Yes. That's farming. You mentioned methane briefly. That is an important topic, and that could dramatically worsen the situation. What can we do about that?
Well, about 3/5 of the methane is actually released by human activity. Some of that's agriculture. The biggest part is actually leaks and flares, especially flares in engineered vents from the hydrocarbon industries, the oil and gas industries. And you might think that flares mean you burn it, but actually a substantial part doesn't get burnt because it's not perfectly efficient combustion, especially if it's not well maintained or if the wind's blowing. You see, many of the oil and gas companies are starting to abate their own methane emissions, but they're kind of in compliance mentality. They're making us do this. Actually, you can create a lot of value from not leaking the stuff, but selling it, and there are more clever ways to separate and sell the product you want at the place you're in. So I'm waiting for one of these giant, very skillful companies, some of which we advise, to actually take this on as a global roll-up opportunity. And the first one to get there can abate not just its own emissions to the degree required, but everybody's emissions that will work with them to the degree that's profitable.
How can not putting methane in the air be profitable?
Not putting methane in the air is profitable because you can sell it as natural gas, or actually, if the leakage is at the well site, there are new microfractionator technologies that let you separate out, for example, bottled cooking gas, butane and propane, and sell that to all the people around, say in Nigeria, who are desperate for cooking fuel as they watch the giant gas flares on the horizon. It turns out that the profitable methane abatement, says the International Energy Agency, in the hydrocarbon industry would be enough to actually stabilize the entire global methane cycle, because it decomposes so quickly in the air. You don't need to stop emitting it altogether in order to stabilize the amount. And in fact, if you overperform on the hydrocarbon opportunity, you can reduce the methane in the air, and that would be the quickest way we know to turn down the global thermostat. It's like we're on this runaway carbon train, and in this little closet we open the door and suddenly we find there's an emergency handbrake. It's not enough to stop the train completely, but we can sure slow it down a lot.
So you've been talking about efficient cars for a long time. I remember the concept of the hypercar was developed by Rocky Mountain Institute. We're getting somewhere there.
Well, I've got a carbon fiber electric car, and the license plate says hypercar, my first one.
There you go.
It's quadruple normal efficiency, and it was profitable to make from the first unit because, as we had been claiming since the 90s, but I don't think anyone quite believed it, manufacturing this car, which is done all with renewable energy, by the way, requires a third the normal capital and water, half the normal energy, space, and time. It's just much simpler.
So, but the electric cars are coming, and what I wanted to say is that it's so hard if you talk about climate projection to model the introduction of electric cars, for instance. In my mind, it seems the same like iPhones, and if you would have needed to project in 2007, when the first iPhone was introduced, how that trajectory would be, it was very hard to predict how fast it would grow.
And you certainly would not have seen, and many of us didn't see, that the way products like this are made, the makers will pay enormous sums to get a little more battery life. So that's driven the innovation in the lithium battery technology, which then made it cost effective to make things like a Tesla car I've also got outside. And when you make a whole bunch of batteries for that by the millions, then the batteries get cheap for everybody. And when that happens, then you could make your solar power on the roof 24/7 at very low extra cost, and then that puts the fossil-fueled power plants out of business much faster. So what we're seeing in the energy revolution is this kind of ripples in a pond spread of causality across complex webs between many different industries that were very hard to foresee. So
nobody would have known.
Nobody would have known. And we're now starting to kind of map those relationships to figure out where are there unexpected links that haven't quite happened yet, but we could help bring them into being.
You've talked to many governments and big companies in the world. Do they get it?
Many get it. How do you change fast enough? Tony Seba, the Venezuelan innovation lecturer at Stanford, has dug up a couple of lovely archive photos from the National Archive in the United States, and they're looking down Fifth Avenue in Manhattan during the Easter parade. In 1900, you have to look very hard to find the first car. In 1913, you have to look even harder to find the last horse. And of course, the horse and buggy operators thought, oh, it'll be okay. We have decades to adapt. All will have retired by then. They'll have to put in filling stations and traffic lights and all this infrastructure, and they'll have to pay for the roads and be paved and so on. Well, they were wrong, because Henry Ford decided to make cars that his workers making the cars could afford to buy. He cut the price, I think, 62% in a 13-year period. And Tony says that the fraction of U.S. households owning a car went from 8 to 80% in a decade. 3/4 of them financed by a General Motors and DuPont financial innovation called car loans.
Yes.
Well, today, 3/4 of our rooftop solar is innovatively financed. Instead of getting 62% cheaper in 13 years, our solar panels got 80% cheaper in 5 years. This revolution's already happened. Basically, Ford's car industry and Edison's electric industry are coming together to eat Rockefeller's oil industry. Yeah. And I think if you look at those two pictures, you realize what's going on is really quite fundamental. The pace of this transformation is not driven by incumbents, but by insurgents.
I was going to say that,
The insurgents are not inhibited by the incumbents' legacy assets or business models or cultures. They can go do their own thing, and being uninhibited and fearless lets you do extraordinary things. So I think a lot of what we need to do is get old habits and out of the way, old assets gracefully retired with a minimum of unavoidable financial damage to the people that bet wrong, and really help the transformation move as it is trying to do at the pace and at the cost of software, not of infrastructure, so that the pace is not constrained by the inertias of incumbents, but sped by the ambition of insurgents.
So you've been indeed working on this for 5 decades, and what do you say now? If you could have a moment that you could actually implement some political measures, some act, something, what would you do to really propel the changes that we need?
The biggest barriers are not technical, they're not economic, they're between our ears. They're in understanding what is possible and where should we put our effort and where should we get out of the way. Renewables are doing so well in the market, they've lately taken about 2/3 of all of the new global electricity generating capacity. So to people who say, oh, these futuristic things may become important one day, I say, dude, what part of they just took 2/3 of your global market don't you get?
Yeah.
So that's now unstoppable. What is already twice as fast but needs to get a lot faster, and people don't see it, it's invisible, it's not on the policy radar so much, is using energy in a way that saves money. And energy efficiency is not the only thing we need to be doing, but it's the most powerful and under-scoped, under-invested in, under-perceived part of the comprehensive energy solution.
Wouldn't it make more sense for you to teach classes or consult with young entrepreneurs, right out of school, to introduce them to all those possibilities and ideas rather than consult with governments that can't move that fast?
My colleagues and I do both. And we are thinking very hard about how to expand both of those activities and get more synergy between them.
So it seems very, rewarding to start a contractors firm to re-engineer houses. But that is not as sexy, if you like, as, for instance, starting a company that builds solar panels or creates whatever next dimension solar panels. So, in other words, what you propose people should do may not be as attractive for an entrepreneur.
Low friction piping and insulating buildings and lightweighting cars may not be as glamorous, but it can make more money at less risk, and people with different risk appetites and technological tastes will gravitate to which of those pursuits they have the most use for. And that's fine. We need both of those things. We need them together. There are strong synergies between renewable supply and efficient use. We've just been underinvesting more in efficiency than in renewables and need to right that balance. And that means a lot of barrier busting, so people are actually free to respond to the market signals that they're getting.
Where do you get your new ideas?
Partly from, shower epiphanies, when one is in that sort of dozy state early in the morning, and maybe theta state, and mostly from talking to other people. So I travel a good deal. I have a fairly large surface area of networks around the world, and most of my new ideas just come from that cross-pollinating.
What's your last idea that made you come smiling out of the shower?
Oh dear, well I can't say because it's too good.
In what direction is it?
I work on supply and demand, and we work in equal depth in all of the energy-using sectors, buildings, mobility, industry, electricity, and how they're all connected. I think I've been able to make more of a difference on the demand side than the supply side. That will continue to be true. And I'm especially pleased with many of the young colleagues and students I've had lately that are going to make a huge difference, and they're better than we were at that age.
Compared to where you started 50 plus years ago, where we are now, aren't we at the threshold of an absolutely exciting moment in terms of economic opportunities, making this a more just and sustainable place, the whole world? I mean, haven't you traveled a long road to get to a very nice and critical point?
The energy revolution is the biggest shift in human affairs since at least agriculture that will give us a richer, fairer, cleaner, cooler, safer world.
What's your problem?
Most of the energy people use is wasted, and we're getting it in costly ways that are killing us, either quickly or slowly.
And what's the solution?
I need to do my part with many others to figure out how to apply much faster and more widely the solutions we already know. We will also develop new and better ones, but the ones we have are sufficient if we actually use them at scale.
Will you ever stop doing this?
Oh no, my parents made it to 97. We'll see how close I get.
So the best idea is yet to come.
I hope so.
Thank you. Bananas are growing in the snow at 7,000 feet. That's Amory Lovins' message of energy efficiency. It's a simple but major solution to reverse global warming. This is the Climate Solutions Summit. Stay tuned.